Math 8 Unit Line, Lesson 1, Part 1. Introduction to Exponents, the origin of exponents, and the law of arithmetic. First, understanding where all of these operations come from. Addition is the most basic operation we have. It's the first operation that mankind learned how to do. Basically, it's co-counting. You'd count two different sets and then you could add them together instead of counting the full set. Another thing about addition is commutative, which means you can do it in either order. 3 plus 7 is the same as 7 plus 3. They both equal 10. It's also associative, but we're not going to talk about that much here. Subtraction is the inverse operation of addition, and all you need to be able to do subtraction is negative numbers, and then you can just change it back to addition. So 3 minus 5 is the same as 3 plus negative 5. And there's the counter model of it. You get 0 pairs here, which gets rid of most of it there. And I want you to consider the following. What do you get if you have nothing to add? Well, 1 plus 1 plus 1 is 4. 1 plus, well, that was 4 ones. 1 plus 1 plus 1 plus is 3. 1 plus 1 is 2. 1 is just 1. If you don't have anything, what would it be? Well, the pattern here would suggest 0. And yet, if you have nothing to add, you get the empty sum, which is 0. That's why when you add 0, nothing changes. Okay, and then we get on into our addition. We want to do it a bunch of times with the same number. And this gives us something called multiplication. You can see that 7 threes being added together is 3 times 7. And if there's nothing to multiply, you actually get 3 times 0, which you should know ends up giving you the empty sum. Anyway, multiplication is repeated addition. And 3 times 7, of course, there you have 3 sevens. But 7 times 3, that's 3 7 times. You get, or sorry, 7 3 times. You get the same answer because multiplication is commutative. It can be done in either order. It gives you the same answer. Now, division is the inverse operation to multiplication. Multiplication when you can include fractions. So we can take care of division by just using fractions, and then we can realize multiplication and division are two sides of the same coin, just like addition and subtraction are. Okay, recall that when you call the answer, what do you call the answer if you have nothing to multiply? So let's take a look here. If we have 2 times 2 times 2 times 2 times 2, that's 32. 5 factors, all of them being 2. What do you get if you have nothing to multiply? You might think it's 0, but it's 1. If you have nothing to multiply, it's like each of these is multiplied by a 1. You just don't need to write it. The empty product is the 1. That's why when you multiply by 1, nothing happens. And if you divide everything away, you're left with 1, not 0. Okay, next we get into these repeated factors, and that's called exponentiation, or most people just call it exponents. Anyway, on this they use a little superscript number to tell you how many times this number is being multiplied. So 3 multiplied by itself 7 times, which I think is 2187, is 3 to the 7th power. 3 multiplied by itself 6 times, which is 729, is 3 to the 6th power, and on up the chain. Now we will talk about this one at the top in a couple of weeks, but yeah, 3 to the 0th is actually 1. So exponents, here's the definition of exponents. We'll get to that in more detail in the next video. One thing to note is exponentiation is not commutative. You cannot do 3 to the 5th and 5 to the 3rd and say they're equal. They are not. So you cannot commute exponentiation. So the definition of exponentiation, if you look here, this is just kind of the regular forward direction. There are two inverse operations for exponents. This is because they're not commutative. The first one, introduced in 8th grade, so you need to know how to do this one. We've actually already done a little bit of this. So if you have an unknown number that you are raising to a power, to an exponent, and you know what the answer is, you can use roots to undo it. So we can un-fifth power this, which would be the 5th root, and then we get back to the original answer, which is 3. That's one of the inverses of exponents. The other inverse you won't get to until 11th grade, but I'll give you a quick overview of it now. They're called logarithms. Logarithms are another inverse operation of exponents that calculates the exponent when the base and the power are known. So we know 3 raised to some power is 243. If we need to figure out what that power is, we have to use logarithms to do it. So this unknown number is log base 3 of 243, which, if you know how to enter that on a calculator, which you'll learn in 11th grade, it ends up just being 5. That's the missing number. So exponents do have two inverse operations. Now all of this comes together to create the law of arithmetic, which most people call it the order of operations. I call it the law of arithmetic for good reason. But you probably know it as PEMDAS. I leave out the D and the S because, well, multiplication and division are kind of the same thing, and addition and subtraction are kind of the same thing. But if you think about how this is built, when operations were built, addition and subtraction are the base operation. Everything is based off of those. Multiplication is just repeated addition. Division is actually repeated subtraction. Exponents, roots, and logarithms would be built on top of that. Now, the reason that when you're doing the order of operations you would do exponents first is because exponents are repeated multiplication. So if you have a bunch of repeated multiplication, you would do it before the rest of the multiplication. It's like you took a bunch of multiplication and packaged it as exponents. You can take a bunch of addition and package it as multiplication. And the only thing missing from here, if you want to change the orders, you use parentheses. So it goes exponents, multiplication, and addition. If you want to change the order, use parentheses. Parentheses pretty much says, do this first. Thanks for watching.